aircraft, began with the study of physics, aerodynamics, combustion theories, and everything. And then you use that theory to come up with the design and come up with a blueprint, and then you use the wind hole, the wind tunnel to do the simulation, everything. All that is part of the system, but at the end of the day, you build an aircraft which actually has maybe 1 million parts. Every nuts and bolt, everything, inside the aircraft is part of a system, and that's a system, presented to the user, and someone will operate and integrate that as a part of the system. So I would like to define system to be that aircraft. Why I do that? Because it is kind of the combination and maybe the result of what we exactly want to build, and also it is meeting a few goals. It is not to be built to emulate certain thing, but it is to actually operate, right? So a system, in my opinion, needs to be operationalizable, needs to be debuggable, okay, and needs to be actionable. And then causal inference in there is not just about mathematical causality or philosophical causality. We all know that it is the wind, the air that lift the aircraft, and we all know that it is the temperature that causes the jets to come out and so forth. And this is a part of causality. But when an aircraft went down in an accident, you actually worry maybe the majority of the reason to be what part inside this aircraft is going wrong. It is very deterministic. And it is possible to debug that because the system is so well kind of compartmentalized and designed and documented and assembled in a repeatable way, right? At that point, statistics actually stops. It's actually very deterministic. It is really about the realization of a great piece of theory, into a mechanical system that people can actually use. Now, when we talk about, a medical diagnostic system, when we talk about, maybe, a treatment kind of robot or, a pipeline, I wonder, how much time it is about that the reasoning and data goes wrong, and how much time it is actually, the implementation of that system itself, which actually involves millions of lines of code, involves container, involves distributed training, involves wiring and chips and everything. All of this actually is part of the system, right? I found to be a little bit troublesome that most of the computer scientists, statisticians, don't even talk about anything other than what is seen in the equation. But that part is actually a very small part of what I see to be a system. So in my opinion, at least, which what I'm trying to build, I would say the end-to-end type of characterization is a user experience. It's to let user experience the end-to-end, but it is not the design principle of the system. The system is actually very matriculated, very, very tedious to be consisting of millions of parts, which someone needs to look into and also able to change and adjust. If we can drive causal inference, to this mechanical and implementational and operational level, that could be, a great new space, for causal inference to discover and to kind of deliver value.